So we're figuring out this information based on just old, tried and true methods of formulas and calculations that we've been using for just regular subnetting, but we just keep using them over and over and over again as we do variable length subnet masking. So in this example here, they already pre-populated the networks they're going to use in this case. So 32.0, 32.64, 32.28, 32.192. Let's go back and see those. It's these four right here that they decided to deploy for those branch offices. Now, do any of these affect any of these? No, not at all. None of those get affected at all, do they? No, not even close to it. Because look at the very last address at the bottom. The very last address is 47.192. The next subnet ID is 48. So we are essentially just hanging out right in here. That's it. We're hanging out in there. We're not interfering with any other subnet. We just picked one of these 16, and that's what we're using in more detail. So subnetting a subnet. So there's our /26s that we see right there, deployed. But I want to show you right here how easy you can do it just in your head. So we know we need 50 hosts, right? And we know the equation to figure out the number of hosts. 2 to the power of something must be, -2 must be greater than or equal to the number of hosts we need. So in this case, 2 to the power of something -2 must be greater than 50 or equal to 50. So 2 to the power of 6 minus 2 gives us 62. Therefore, we need to have 6 host bits left over. So what's our new subnet mask? Our new subnet mask is going to be 32 minus 6. The new subnet mask is 26/26, which is 255.255.255.192. So what's the block size now? That's the next key critical ingredient. The block size is going to tell us what we're counting by for every single subnet ID. So how do we figure that out again? Well, you just simply determine where the very last one is in that subnet mask in binary and whatever that decimal value is. Or you can take this shortcut right here, take the value 256 and subtract it from that most significant octet. So in this case, the most significant octet is the very last octet because that's one we're counting in. So we've got a 192, say 256 minus 192 equals 64. There's a nice little shortcut. 256 minus 192. So we have a value of 64 in this case. So we're counting by 64 in the fourth octet. 32.0, 32.64, 32.128, 32.192, then 33.0, 33.64, etc., etc. So we took the first 4, we plugged them in right there. All right, so now let's focus on our WAN links. Because the WAN links now, we want to be efficient with those as well. We only need 2 hosts. Well, are we going to deploy a /20 there? No. Are we going to deploy a /26 there? No. But let's take our 172.16.33.0/26 network. Right, so let's take that very last one here, the 5th one, I should say, because there's a lot more than that. We created 64 subnets here. So we're taking the 5th out of 64 of them, and we're going to subnet it again. That's right, we're going to subnet it down to a /30. So what's that going to look like for us? What is that going to look like for us? Well, we can see here that we are taking 172.16.33.0/26, and now let's break that up. So we know to get a /30, we have to have 2 host bits left over, because 2 to the power of 2 minus 2 is 2. So for our new subnet mask, we have our /30. What's the block size? Well, 255, 255, 255, 252. Take 256, subtract 252, you get a block size of 4. So we already know it's /30, so knowing that the block size is 4 every time for a /30 is going to save you time. /30 always has a block size of 4, no matter what. So that means you're counting by 4 in the 4th octet every time, no matter what. So in this case, you have 33.0, 33.4, 33.8, 33.16, 33.12, 33.16, and they're all /30s. So let's go ahead and put 33.0 there, 33.4 there, 33.8 there, 33.12 there. All right, and we have leftovers. So we have leftovers. We're going to have leftovers, but they're all /30s that are left over. So at any point in time, if we ever need to have additional WAN links added for additional branch offices, we have /30s we can go ahead and utilize. Likewise, with the LAN subnets, we definitely have leftovers there as well. Why? Because when we did our subnetting down to a /26, how many subnets did we create? Well, we were a /20, now we're a /26. That's 6 bits we had to borrow. So 2 to the power of 6 is 64. So we created 64 subnets in total. We only used 4 of them right now. Oop, no. Let me correct myself. 5, right? 5. We used 4 for the branches and 1 for the WANs. We took one of those /26s and we turned them into /30s. Turned them into /30. So how many are left over now? Well, we had 64. Now we got, what, 59 left over? Let's keep that in mind. Keep that in mind. That when you are performing subnetting, you're using variable length subnet masking, you can be much more efficient as we've done here. If we weren't efficient, then we'd have to take /20s and deploy them everywhere. And that would have a whole bunch of wasted addresses. So instead, we subnetted the /20 down to /26s, and then we took a /26 and we subnetted down to /30, and we addressed the entire network with just one /20 in this case.